Hello everyone, welcome to One Stop Mathematical Solutions. Let's start solving IIT JAM MCQs. These are from 2017 question paper. Let S be an infinite subset of R such that S excluding A is compact. Then which of the following is true? And that A is nothing but a real number actually. Okay. So let's start with the given condition. S excluding singleton A is compact set, but also we know that singleton A is a compact set. And why we say that? Because singleton A is a closed set as well as a bounded set. So all finite sets will be compact. Okay, so S excluding singleton A union singleton A, what will this be? This is also a compact set because finite union of compact sets is also compact. So what is the set that we have here? S excluding A and union A is just S. So we arrive at a solution. S is compact. And there is one theorem in compact sets. If S is compact, then every sequence in S has a subsequence which converges to an element in S. So option D is the correct answer. Next question, we have a differentiable function f and f of 2 equal to 2 and a condition on f is given, and g of x is x cube f of x. We need to find g dash of 2. So let's start by finding f dash of x first. It can be found from this condition given. So modulus f of x minus f of y is less than or equal to 5 modulus x minus y the whole power 3 by 2. But what is f dash of x? F dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. So this is almost like the same. I'm gonna take the modulus now, and h is a positive quantity, right? So here it's actually instead of x we have x plus h, and instead of y we have x. Let me write the modulus for the numerator alone now. Now we can apply the inequality given. So limit h tends to 0, 5 modulus of instead of x we have x plus h minus instead of y we have x the whole power 3 by 2 divided by h. So the x will get cancelled and we are left with 5 h by h, sorry, h power 3 by 2 by h. So limit h tends to 0, 5 into h power 1 by 2. When you apply the limit, this will be 0. So modulus f dash of x is 0, is actually less than or equal to 0. So this gives us f dash of x is equal to 0, which then implies f of x is equal to a constant number. Now let's use the given condition f of 2 equal to 2. Yeah, f of 2 equal to 2. Since f of x is constant for every x, c is must be equal to 2. So f of x equal to 2 for all x. Now let's use this one. G of x is given by x cube f of x, which means 2x cube. What is g dash of x? It is 2 into 3 times x square, which is 6x square, and g dash of 2 will be 6 into 2 square, which is 24. So the answer is option D, 24. The next question, we have a vector function and a circle oriented anticlockwise. We need to find the integral f dot dr. And to be noted, a and b are positive numbers. So let's start with the f. It is xi minus yj divided by b square x square plus a square y square, and c is the set of all x comma y in R square such that x square plus y square equal to a square plus b square. Since a and b are positive, I'm gonna take a and b as 1. So f is xi minus yj divided by x square plus y square, and c will become set of all x comma y in R2 such that x square plus y square equal to 1 plus 1, that is 2. So let's try to find the integral now. Integral over c f dot dr. Here c is actually a circle with radius 2. So f xi minus yj by x square plus y square and dot dr. What is dr? Dr is nothing but dxi plus dyj. So multiplying two vectors, we will multiply the corresponding terms. So x dx minus y dy by x square plus y square. I'm gonna write it in the form integral over c m dx plus n dy, where m is this part and n is this one. So let's write it clearly. M is x by x square plus y square, and n is minus y by x square plus y square. Since m and n are not they have the denominator x square plus y square, which means they are not continuous at 0, 0. So this implies that we cannot apply Green's theorem on the whole C. We need to remove the point where it is not continuous. So I'm gonna remove 0, 0 by making a small hole in the middle, and I'm gonna connect that to the end of the circle. So let's name the small circle as S and the paths as C1 and C2. It's all oriented anti-clockwise. Great. Now the curve C dash, the new curve is C plus S plus C1 plus C2. So integral over C will be the summation of the integrals over these curves. So let's start with C1 now. Integral over C1 and integral over C2 will be same, but since they are in opposite direction, we have a negative sign. And integral over C dash will be the integral over C plus the integral over S, and the C1 C2 will get cancelled because both are like opposite. Now Integral over c dash is also 0. Why is that? Because in c dash the function is continuous, right? So we are left with integral over c is equal to negative integral over s. Now our problem of finding integral over c is now just to find the integral over s. Here I'm gonna change it to polar form because that will be very easy to integrate. So I'm writing x as r cos theta and y as r sin theta, differentiating that with respect to I'm just finding the derivatives. So dx is equal to minus r sin theta d theta and dy equal to r cos theta d theta. So the integral over s will be integral over s x dx. Instead of x I'm gonna straight away write r cos theta into minus r sin theta d theta divided by x square plus y square is nothing but r square, because the cos square plus sin square will eventually become 1, and n is actually minus y, right? So minus r sin theta into r cos theta d theta divided by r square. Actually both terms are same, so I'm gonna add it now. So this is integral over s minus 2 sin theta cos theta d theta, because r squares are getting cancelled. So this is same as writing minus sine 2 theta, because 2 sin theta cos theta is sine 2 theta, and d theta. Now we can take the limit from 0 to 2 pi, because there is a negative again. So integral over c m dx plus n dy is integral 0 to 2 pi, and the negative sign will get cancelled, so we just have this integral. And let's just apply this and find the value. So integrating that, we get cos 2 theta by 2, 0 to 2 pi. First, when you apply 2 pi, you get cos 4 pi by 2 minus cos 0 by 2. Cos 4 pi is 1 and cos 0 is 1, so the answer is 0. Option D is the correct answer. Okay, now we have a series n equal to 1 to infinity tan inverse of 2 by n square. I'm gonna start by writing it as summation n equal to 1 to infinity tan inverse of n plus 1 minus tan inverse of n minus 1. So to see how this comes, let's see a formula of tan inverse, that is tan inverse of x minus tan inverse of y equal to tan inverse of x minus y divided by 1 plus xy. So instead of x you can put n plus 1, and instead of y you can put n minus 1. So this will be tan inverse of n plus 1 minus n minus 1 divided by 1 plus n plus 1 into n minus 1. When you simplify this, you will get tan inverse of 2 divided by 1 plus n square minus 1, so just 2 by n square. So So that's why I have replaced this with this expression. Now I'm gonna replace the sum, infinite sum, as limit and a finite sum. So limit m tends to infinity, sum is from n equal to 1 to m. So since we have a finite sum, let's just expand it. The first term will be n equal to 1. For n equal to 1, we have tan inverse of 2 minus tan inverse of 0, plus for n equal to 2, tan inverse of 3 minus tan inverse of 1. Again, the next term is tan inverse of 4 minus tan inverse of 2. The next term is tan inverse of 5 minus tan inverse of 3. And the last term is n equal to m. I'm gonna write last 3 terms now, because that will show us which terms are getting cancelled. So tan inverse of m minus 2 plus 1 minus tan inverse of m minus 2 minus 1, and tan inverse of m minus 1 plus 1 minus tan inverse of m minus 1 minus 1, plus tan inverse of m plus 1 minus tan inverse of m minus 1. So the last 3 terms for n equal to m, m minus 1 and m minus 2. Great. Now the terms are getting cancelled. You can see it here. If you see that the last m minus 2 plus 1 is m minus 1, and this one is m minus 3, this one is m, and it's actually a minus, so it is m minus 2. So you can see that this m minus 1 and this m minus 1 will get cancelled, and actually if you go backwards, these two terms will also be cancelled. Let's write the remaining terms. Limit m tends to infinity, tan minus tan inverse of 0 minus, actually it is minus, yeah, minus tan inverse of 1 plus tan inverse of m and plus tan inverse of m plus 1. Now what is tan inverse of 0? It's just 0, right? So I'm gonna take these finite values outside the limit. So tan inverse of 0 will be 0. First let me write the finite numbers. So 0 minus tan inverse of 1 will be pi by 4. Then we can apply the limits to the remaining values, which involves m actually. So when you apply this m tends to infinity, you will be getting tan inverse of infinity and again and tan inverse of infinity. And what is tan inverse of infinity? It's pi by 2, right? So minus pi by 4 plus pi by 2 plus pi by 2. If you take LCM, you get minus pi plus 2 pi plus 2 pi. So the answer is 3 pi by 4. Option C is the correct answer. Next question, we have a vector function f and the boundary of triangle with vertices is given. We need to find the function when viewed from the point 2 comma 2 comma 2, which means we are just gonna find the integral f dr. So f is actually zxi plus xyj plus yzk, and the integral, okay, before let me write the points of triangle first. A is 1 0 0, B is 0 1 0, and C is 0 0 1. first let's find the integral from a to b. For that we need a line AB, right? So what is the equation of a line? X minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 divided by z2 minus z1. And these ratios will be equal to a constant t, where t is between 0 and 1. So equating these separately to t, before that let me simplify it. So x will be minus t plus 1 and y equal to t and z will be 0. So this will give the equation of line AB. So integral a to b f dot dr is equal to integral, the point A is 1 0 0, point B is 0 1 0. F dot dr will be zx dx plus xy dy plus yz dz. Here zx, xy, yz are I, j, k components of f, and dr is dxi plus dyj plus dzk. That's why the corresponding terms are multiplied here. Now let's try to replace it with the parametric equation and t. So the integral a to b, it is 1 minus t t dt, because the first and last term are 0. Integrating this one will get t square by 2 minus t cube by 3 from 0 to 1. Applying the upper value we get 1 by 2 minus 1 by 3, and the lower value will give 0 only. So the answer for this is, if we take LCM, it is 6. 3 minus 1, sorry, 2 will be 1 by 6. Let's do the same for the integral from b to c and c to a. Actually all of those will be same. The lines are x minus 0 by 0 minus 0 equal to y minus 1 by 0 minus 1 equal to z minus 0 by 1 minus 0, and t is from 0 to 1. After you simplify this, when you have the separate equation, you will get x equal to 0, y equal to minus t plus 1, z equal to t. When you apply in the integration from b to c, zx dx plus xy dy plus yz dz equal to integral, again zx and xy will be 0 and yz will be 1 minus t into t dt, and the integral is from 0 to 1. It is same as before, right? So this integral is also 1 by 6. And similarly you can try the third one from c to a. And that will also be 1 by 6. So on the whole, the integral f dr is the sum of all these three. So the sum is 3 by 6, which is 1 by 2. So the answer is option C, 1 by 2.